Hi, I'm Katie Poggensee, and I'm part of the Stanford Biomechatronics lab. We're interested in how people learn how to use ankle exoskeletons. We previously found a solution for a slightly different question. How do we teach exoskeletons to work with people? As a few people from our group mentioned, we use a method called human-in-the-loop optimization. Simply put, a generation of candidate controllers is sampled based on our current best guess and is then applied to the human exoskeleton system. A measure of human performance, here an estimate of metabolic rate over 2 minutes, is used to rank the different controllers. An optimization algorithm then determines the next generation of control laws, moving in the direction of controllers to minimize energy cost. The optimized controller for a unilateral ankle exoskeleton resulted in a 24.2% reduction in metabolic cost across users. So how do we help our users get the most out of human-in-the-loop optimization? To answer that, we should understand why it works. Maybe we found a generically good pattern that is intuitive for all users. Maybe there's some additional benefit to customization. And maybe it has nothing to do with the device and is really just about the person's experience adapting with the exoskeleton. So let's dig a little deeper into that one. In our initial study, participants spent over an hour walking in the exoskeleton, experiencing different assistance profiles until the optimizer can find the optimal controller for that person. We know that exposure time is an important factor for motor learning, but how subjects spend their time is also important. Is practicing the specific task, in this case the optimal controller, most beneficial? Is variation necessary for adaptation? Or does some combination of variation converging on the optimal controller result in the best outcomes? So we designed an experiment to understand the different contributions of an intuitive generic assistance profile, customization, and training using our bilateral ankle exoskeletons. For every day of the experiment, we measured kinematics, ground reaction forces, lower limb muscle activity, and metabolic cost. Participants began with a pre-test where they walked with normal running shoes, an unpowered zero torque mode, and with generic assistance as a baseline for novice users. For the 5 subsequent days of the experiment, participants started with an adaptation trial, followed by validation trials testing those baseline conditions, and the generic assistance profile to track how people learned how to use the device. Participants were randomly assigned to one of 3 training groups. The continued optimization group began with large variation before tapering to less. The static group experienced the same profile the entire trial, thus had no variation in training. And the re-optimization group experienced the same optimization as the first group, but it was reset at the beginning of each day, so the average variation remained high. The optimization algorithm used for the training protocol yielded a custom optimized profile, which was then tested alongside the other validation trials. So in the pretest, which accounts for 12 lifetime minutes of assisted walking, we saw a slight improvement in energy economy with assistance. However, after several days of training, participants were able to triple the energy savings with the same assistance profile. And customization can lead to even greater metabolic cost reductions, but only if the people are fully trained and the optimizer has enough time to find the optimal solution. Adaptation took a really long time for all of our users, and moderate variation speeds adaptation, but does not necessarily result in better energy economy in the long term. People adapt in other dimensions as well as they gradually reduce their energy cost. For example, they adapt kinematics to reduce the mechanical power derived from the device. For more information on how these adaptations occur throughout training, tune in tomorrow to hear Sabrina Abram explore this topic. So in summary, people can successfully use generic or customized assistance, although customization can provide greater benefits. And the length and type of training matters. Failures of previous exoskeletons to deliver benefits may have actually been failures of training. Thanks.